and we are doing BSc. This is N5. Okay, so we are going to be doing a new topic today, and this is the topic of frames. Okay, so here we go. In today's topic, we'll be dealing with frames. Okay, we're going to start with the Bose notation. Now, Bose notation is just a way of naming each member in the frame. And that's the first question is use Bose notation to name each member of the frame. Okay, and then after that, we are going to calculate the reaction forces L and R. There's L over there and R over there. Okay, now in naming each member in this frame, you always name it in a clockwise manner. Okay, if you can just imagine a spiral going that way. Okay, so we're going to start there. We'll name this member A. We're going on a clockwise direction, so that's going to be B. That's C. Now D is this whole member there. Okay, and now remember, because we are going in a clockwise direction like a spiral, this one here, we're going to name it E, F, G, such that each member will be two letters. So this member here is going to be A, E. This member here is B, F. This member here is C, G, and so on and so on. Okay, we are done with the Bose notation. Now let's go and calculate the reactions. Okay, in order to calculate the reactions, we are going to use moments. Okay, now a moment is basically force times distance. Okay, and you take a moment about a point. So we are going to take a moment about the point L, there where L is. Okay, and the moment there about the point L should equal 0. Okay, and we're gonna take it as clockwise being positive. Okay, so that means what you must do is that, let's look at this properly. I want us to see all the forces there. Okay, you see that the first force is 10 kilonewtons. Okay, and it's going down, and from there it's at a distance of 0.5 meters. Now what I always do is that I like to put my finger there. Or let me just put a pencil to make sure that I know where I'm taking the moment from. Okay, from that point. So such that now I'm going to say, okay, the first force I'm going to encounter is 10 kilonewtons. And if my pencil is there and 10 is pushing there, then the whole frame is going in a clockwise direction like that. Clockwise direction like that. Okay, so the force is 10, it's positive, and it's at a distance of 0.5. The next one, it's also going on a clockwise direction. That one is 15. Okay, and it's at a distance of 1.5 meters. Now the next one is this R. Now you see the force R is going that way, so it's going to cause the frame to go on an anti-clockwise direction. And because it's going on an anti-clockwise, we can put an equal sign and then put it on the other side of the equal sign, which will make it positive. It's going to be r times the distance of 1, 2. Remember, if I put it on this side of the equation, then it would have been negative, and then everything would be equal to 0. But I just prefer putting it on the other side so that things are more clear. Okay, now the next thing to do is just solve for that r. Okay, we're going to use a calculator. Okay, and then we're going to say 10 times 0.5 plus 15 times 1.5, and we're going to get 27.5, and then we need to divide it by 2, that 2, in order to get what r is. So we're going to say divide by 2, and we get r is 13.75 kilo newtons. All right, we're going to do the same for the calculation of L. Okay, so we're just going to put it there. Let's just split that there and take the moment now about r. Okay, and the moments there must be equal to 0. Yeah, still let's take clockwise as positive. Okay, so now we are standing there now. We put our pencil there. All right, we're standing there, and it starts this side. We have L, a force of L, and it's at a distance of 2 meters from R. Okay, so it's going clockwise. Now, as you can see from here, that's now these forces are causing, if you're standing here, are causing the frame to go anti-clockwise. So we're just going to put an equal sign to put them on the other side so that they'll be positive instead of negative. So the first force is 10 times, it's at a distance of 1.5, plus 15, that's the one, it's at a distance of 0.5 from R. Okay, so we can go ahead and put this in a calculator now. Let's see what we get. Okay, so we have 10 times 1.5 plus 15 times 0.5. Okay, is equal to that divided by 2, and we get 11.25. So L is equal to 11.25 kilonewtons. Now, you do not end there. You need to do a check just to make sure that your answers are correct. So you will say check. Now you're checking that the upward forces are equal to the downward forces. All right. So what upward forces do we have? We have L and R. We have solved L to be 11.25 plus R is 13.75. Now we want to check if this is going to be equal to our downward forces. Our downward forces, we had 10 and 15. So we're going to say 10 plus 15. Then we're going to take our calculator. We'll start with this side. 11.25 plus 13.75 is equal to 25. Okay. On the other side, let's do the other side now. 10 plus 15 is 25. 25. Therefore, our left-hand side is equal to our right-hand side, which means it is correct. Our reaction forces are actually correct. So that's how you check them. Okay, now we're done. Stay tuned for the next part of this question. So today we'll be doing and continuing on our topic of frames, graphical calculation of forces. Now the typical question would be to calculate the forces in each member. Now let's get right into it. Right, so how you do this is that if you look there, you have A and B. So the first point is to consider a point, put a point there, and call it A. Now, between A and B, moving from A to B, there's a force of 10 kilonewtons going down. Now you realize right there that we need a force scale, which is a scale that is going to be representative of the kilonewtons on the ruler. Now we're going to choose 1 centimeter is to 1 kilonewton. Okay, that's our force scale. That means that we can take our ruler, since 1 kilonewtons represents 1 centimeter, that means we can draw a vertical line going down, which is going to be 10 centimeters right there. A point, it ends there. So that is our point B. Going back to our diagram, we have from B to C, we have 15 kilonewtons going down. So we go back there. That means that from B, we draw down, move down 15 kilonewtons. And it ends there. So that's going to be our C. Now if you go back to our frame, from C to D, 13.75, and it's going up. So from C, which is there, we need to measure 13.75. 5, 6, 7.5 is somewhere there. Okay, and it must take us back to 0 up there. So we're going to do this just to measure it up nicely. So right there, we call that one D. And then from D to A, we move up 11.25 kilonewtons. Now this should take us back to 0. If it does not, then it means we did something wrong. So 11.25, somewhere there. And indeed, it does take us back to A. Right, now we are done with the vertical forces. Now, to continue with this question, we will need a protractor, because we need to draw A, E. Okay, from A to E, we see that the force is on a 45-degree incline or decline starting from top. So we know where A is, we do not know where E is. on our force diagram. So on top is 45 degrees, so we're going to measure 45 just like that. Okay, 30, 40, 45, it's right there. 45 is right there. Okay, and now what we're going to do, so we're going to take our ruler and we're going to draw a faint line or a construction line that passes up, that's at a 45-degree angle like that. Okay, we'll end it then. The next line to draw will be ED, because our force will be traveling, will be on a horizontal. ED. ED, we still don't know where E is, but we know where D is. Okay, and it's a horizontal force. So we go down to D. Okay, so there's our D there, and it's horizontal. Wherever they will meet with this line, that's gonna be, let me just extend this line first so that it will be able to meet with D. There we go. Now this one I can draw it solid. It's not going to be a construction line, it's solid. And then I'll go ahead and make this one solid. Just like that. Just for, I rub that little bit off that we do not need, so that for neatness sake. And that point where they met, that's the point I'm going to call it E. All right. Now the next one to draw is EF. Now you can see EEF is actually on an incline of 45, again 45 degrees going that way from EF. We know where E is, so we can just straight take our compass. It's 45 degrees this side, so it's 45 is there. All right, and then we'll draw our construction line. Now we do not know which side the next point is gonna be, so we can just our construction line goes past E, because we don't know whether it's gonna be this side or this side, the next point, EF. But here we have BF, okay, and it's a horizontal line. We know where B is, we don't know where F is on our force diagram. Okay, so this B is a horizontal line from B. Draw our horizontal line like that. There, it's a solid line. And where they meet, that's our point F. Okay, now I can go ahead and rub for neatness. Rub these parts that we do not need. Okay, and then make this one solid. Just like that. Okay, the next one to draw is FG. As you can see, FG is 45 degrees on an incline of 45 degrees that way. So we take our ruler, our compass, put it there, measure 45 this side, okay, 30, 45 is there, mark our point there. Now because we're also not sure which side our next point is going to be, so our construction line will just be on both sides like that. Okay, then our next one will be we just did, which one did we do? FG. So we can do GD. All right, GD, and it's a horizontal. We know where D is. There's D. So we'll just extend there. Like that. We don't need this part over here. We don't need this part. We'll go ahead and make this one solid. And that's our G. Okay. And then our last one is GC. It's on an incline of 45. Or we have G there and we have C there. We can just connect them. If they do not make a 45 degree, then we would have done something wrong. They should, in effect, be at a 45 degree. So just to measure my 45 down there. Okay, let's go. My ruler is not long enough, but I'm just gonna go with a limb. Okay, so that's from C to G. If I am to measure this, should be at a 45. C. Absolutely, that's it. We're good. So we are done with our force diagram. Now all we have to do is write the members. So we have member AE. So we write AE, always the members. The next member is ED. All right, ED. The next one is EF. So we go EF. The next one is FB. So we go FB. And the next one is FG. And the next one is GD. So we write GD. And the last one is GC. All right, GC. Okay, now what we need to measure is the forces. Okay, so we can just draw a line just for neatness. Now to get the forces of each of the members, we need to measure from our force diagram the distance or the centimeters of each of the members. For example, AE, we go to the force diagram, we look for AE. So this is A up there to E down here. So we need to measure that, how long that is going to be. Okay, so in measuring that, we're just gonna simply put our ruler there, measure that distance, and it gives me about 15 or 16. Let's say 16. Remember, our force scale is 1 centimeter is to 1 kilonewtons, which means whatever centimeter I measure is the number of kilonewtons as well. Okay, the next one is ED. There is E there, D over there. So we put our ruler, okay, 11.2. So come there, all right, 11.2 kilonewtons. Okay, the next one is EF. Okay, there's E, there's F, so let's measure that. We get about 2 kilonewtons. FB, there's F, there's B. It's about 12.123. 12.3 kilonewtons. The next one is FG. FG, okay, is F, is G. Measure that. It's also about, let's say it's also about 2 kilonewtons. And then the next one is GD. Where's G? There's G. And there's D over there. So we measure by 13.5 kilonewtons. And then the last one is GC. All right. There's a G over there and a C down here. So we just measure that. It's about 19.5 kilonewtons. And that's it. That's how you calculate your forces graphically of a frame using a force diagram. Thank you very much. Today we're doing the last segment to frames, and we'll be talking about the nature of the members of the frame. Okay, now just to get right into it, the nature is such that if a member is facing compressive forces, we say that member is called a strut. But if it's facing tensile, then we call it a tie. Okay, you can always remember by saying TT, tensile for tie, and then the other one is just a compressive one, a strut. It's an easy way of remembering it. Now, how we're going to do this is that to know each member, we're going to have to take each member. For example, just to get straight into it, member AE, this member over here. Okay, so we isolate that member and we go and stand on its far left. So if I put my pen right there on its far left, if I'm standing there and then I move in a clockwise direction, meaning that way. Okay, so if I move on a clockwise direction, I'm moving from A to E. That's moving on a clockwise direction. From there, now that I know that it's AE, I go to the force diagram and I look which direction AE is moving. So AE is moving from that way to that way. It's from there to there. It's moving this way. All right. So I take that very direction and I place it there where I was standing. Okay, and then I just, to balance the force, I put the equal but opposite direction. Now what this member is doing is that it's trying to pull itself apart. Okay, it's trying to pull itself apart, which means it's facing a compressive force, thus making it a strut. So we go there and we're going to write strut. Okay, the next member is ED. Where is ED? ED. Okay, so that's that member ED. It's that member there. And then we go to its far left. Its far left is right there. We move on a clockwise direction. We're moving from E to D. Okay, now that we've established E to D, we go to our force diagram. There's E and there's D. So moving from E to D, we are moving on that direction there. Moving that way. Okay, I take the direction, I put it right there where I was standing. Okay, and then I balance it. Okay, so what's happening here? This member is trying to push itself together. That means it's expressing tensile forces. Okay, and that makes it a tie. So we go right there. The nature is such that it's a tie. The next one is EF. Okay, there's EF, so it's that member there. Okay, we go to its far left. Its far left is over here. Okay, and then we move on a clockwise direction and we hit FE. So we go FE. We've established that. We go to our force diagram. There's F right there and there's E. So it's moving that way. We take that direction, put it right there where we were standing, and then we balance it. Okay, so what is it doing? It's trying to push itself together. That means it's experiencing a tensile force, that's making it a tie. Okay, the next one is FB. All right, FB, where's that member FB? FB, okay, so it's that member there. We go to the far left, which is right there of FB. Okay, so we go move clockwise. If we move clockwise, we're moving from B to F. We go to our force diagram. There's B and there's F right there. So from B to F, we're going that way. Okay, so we take that direction, put it right there where we were standing, and then we balance it. Okay, so what is it doing? Well, it's trying to pull itself apart. That means it's experiencing compressive forces, thus making it a strut. A strut. Okay, the next one is FG. Remember FG? FG. Okay, so it's that member there. We go stand on its far left, right there, and we move clockwise. So we are moving from F to G. We go to our force diagram. There's F and there's G, so we are going that way. We take that, remember we're standing there in that direction, and we put it right there, and then we balance it. So it's expressing itself by pulling itself apart. Therefore, it means it's experiencing compressive forces. That's making it a strut. Next one is GD. All right, there's G and there's D, so it's that member over there, GD. We stand on the far left of it, which is there. Then we move on a clockwise direction. So we're moving from G to D, and we go to our force diagram. We look for G, there's G, and then there's D. So we're moving GD, we're moving that way. So we take that direction, we put it right there where we were standing, and we balance it. So the member is actually trying to pull itself together. Therefore, it means it's experiencing some tensile forces. That's making it a tie. Okay. The last one is GC. GC, so it's this member over here. We stand on the far left right here. We move clockwise. We're going from C to G. We go from C to G, come to our force diagram. C to G is moving that way. It's moving that way. We take that, put it right there where we were standing, and then we balance it. So it's trying to pull itself apart. That means it's experiencing a compressive force, thus making it a strut. And that right there is how we determine the nature of the members of a truss. Well, I hope you understood that. Thank you very much.
Well, that's it. Well, I hope you understood everything I was trying to teach you over there. But in the event that you didn't, please talk to your local lecturer in your local campus. They should be able to help you with anything concerning these.